Maybe
here
they had
earlier
that
to
one
hear it.
set in case these new ones didn't work.
Alright, go ahead and get out your homework.
I always forget that we like do it right after class, and then
You probably finished most of it in class. Right?
I know I got to the 1 and 3 already. As always.
I thought personally in number 3 that they should have told you the mass of the object as well, because all you know is the net force. So I guess we just assume that the masses are all the same. Alright, so what did you put for number 1? A, good. 2A,
16,
B,
32,
C,
4,
D.
4.
What do we say for D?
4.
That's the bell to start class.
Yeah, I guess.
But
D should also be 4. If the mass is increased by a factor of 2, then the acceleration will decrease by a factor of 2. E,
32.
right, okay, so you have to keep in mind that mass is the inverse relationship. So if it's decreasing, then the acceleration is going to do the opposite of that. So the acceleration will be increasing by a factor of 4. So you'd multiply by 4. Okay, and then F, G, and H combine the 2. What did you get for F?
64.
64. Good, because the net force is increasing by a factor of 2, so the acceleration will also increase by a factor of 2. And since the mass is decreasing by a factor of 4, the acceleration will increase by a factor of 4. So you'll be multiplying by 2 and multiplying by 4, or multiplying by 8 to get 64. G,
16.
16, good. H, 96, good. And then what order did you put those in for number 3?
Got B, D, A, C.
Oh, yeah, oh, it does say largest to smallest. I actually put mine in smallest to largest. So, which is the largest? C, and then A, B, B. Mine are backwards, maybe you put yours least to greatest too. Very good. Any questions about that? Okay, you got your notes, please. There's going to get very mathy, which is my personal favorite.
So long as it doesn't include words, I'm all good.
Wait, what did you
Well,
say? It's gonna get very
it
mad.
doesn't include words.
I said nappy.
You know, and
Like, I can take it
probably
in.
gonna happen. So go ahead and write that down, how to find, we're finding the acceleration today, and then we'll do a couple examples. to write down that example, please. Okay. So today we're going to be finding the acceleration for we'll go back down to that, which for what are going to be some word problems. The first thing you need to do is determine all the forces that are present and draw a free body diagram for the forces. And then you might have to do some calculating to determine the values of the forces in order to calculate the net force. so, some of the formulas that you might, two of the formulas that you might use to do the calculating is to calculate gravity. Gravity, remember, is mass times gravity, which is 9.8. And friction, mu is the coefficient of friction, and then times the normal force. And in order to figure out what the normal force is, you might also have to figure out gravity. Usually, with most objects, their gravity and the normal force are balanced, right? So if we could figure out what the gravity of the object is, the normal force is typically equal to that, unless, I don't know, it's, usually they're equal. And then after that, we can calculate the acceleration once we get the net force. Okay, so for example 1, a rightward force of 52 newtons is applied to a 4.2 kilogram box to accelerate it to the right across the frictional surface. The box encounters 31 newtons of friction. Determine the acceleration of the box. Okay, so what would our free body diagram look like? What forces do we have? Applied force, what direction is that going? To the right. Good. And do we know how many newtons that is? Okay. What else?
Friction.
Friction, which direction would that be going?
Left.
Left.
It's 31 newtons.
Okay. And what other forces are present? Gravity. And
Normal.
normal. And we don't need to know those numbers because since it's sitting on the surface, we can assume that the gravity and the normal forces are balanced, so it doesn't really matter what their values are. Okay? From this free body diagram, we are going to calculate the net force. What would it be? 21 newtons, right? So if we subtract, the normal and the gravity are balanced. If we subtract the 52 minus the 31, we get 21 newtons. And we do need to know the direction of that, which is going to be right. Okay? And so from there we can calculate the acceleration. Acceleration is net force divided by mass. And I believe the mass was given to us in the problem. Yes. Okay? So acceleration equals its net force divided by mass. Our net force is what? 21 newtons, right? And the mass is 4.2 kilograms. And what?
You leave in kilograms?
Well, acceleration is actually going to be in meters per second squared. If we go back and say what newtons means, newtons is by definition the amount of, I forget, the amount the amount of force needed to move 1 kilogram 1 meter per second 1 meter per second. So if we do all of the units, we would get meters per second squared for acceleration.
Okay.
And that will give us what? 5? So 5 meters per second squared, right. Acceleration does need a direction. If you have newtons over kilograms, your acceleration is going to be in meters per second squared. Okay? Example 2. A 188 Newton rightward force is applied to push a 29.5 kilogram chest of drawers across a wooden floor. The coefficient of sliding friction between the chest and the floor is 0.556. Determine the acceleration of the chest of drawers. Okay, so if you guys, and you're probably writing all of this down, if you want to just write down the important parts, there's 188 Newton rightward force that's applied, so that'd be an applied force. The mass of the chest is 29.5 kilograms, and the coefficient of sliding friction is 0.556. So again, first we're going to draw a free body diagram. What forces do we have? Okay, good. So we have, again, we have an applied force to the right, and they do tell us that it is 188 newtons. What else? It is, but we're not going to put that on our free body diagram.
Friction is 0.556.
Okay, we have friction, but we don't know how many newtons the friction is, so we're going to have to calculate that later. Because we need to know that. We know that the coefficient of sliding friction, that's the mu number. We know what that is, but we don't know how many newtons the friction is yet. What other forces are going to be present?
Gravity.
Gravity. And normal. And again, those should be balanced, so we don't really need to know what they are. We do need to figure out what the friction is in order to calculate the net force. So if you look back at your formulas, friction equals mu times the normal force. Okay, so I guess we are going to have to calculate the normal force also. Okay, the only thing that we know, and the other formula that we are going to need to know is gravity equals mass times gravity, which I'm just going to put 9.8. Okay. So we know what mu is from the problem, and we also know what mass is from the problem, but we don't know what the normal force is. But we know that the normal force is going to be balanced with the gravity. So first we're going to calculate the gravity. So F grav, the force of gravity, is going to be 9.8 times the mass, which was what?
29.5.
29.5. So gravity is, what is it? 289. 289.1. And that is going to be, that is going to be balanced with the normal force. So we can then use that in this formula to find what the friction is. So then we have friction equals mu, which is that 0.556 times the normal force, which is gonna be 289.1. And that will give us the force of friction, which is what? Good, 160.7. Okay, so then finally I can calculate what the net force is. So the net force is going to be what? Right, we subtract 180 minus 160.7 and get 27.3 newtons, what?
Right.
Right. Okay, and then we can calculate the acceleration, which is the net force divided by the mass, so 27.3 Newton right divided by 29.5 kilograms will give us 0.9. I wrote down 0.924.
That's what I got.
Okay.
I got like 925 something. I got 1.0.
Did you do 29.5 on the top? No? You'd have, it should be less than 1 because the top's smaller than the bottom. 27.3 divided by 29.5. Oh yeah, mine does say 0.925. Well, anyway, it would be about 0.93, I guess we could say. Meters per second. Right. Okay. Alright, and again, if you just want to write down the important parts here. Last example, a 3,800 Newton upward tension force is used to accelerate a 320 kilogram freight elevator from rest. Determine the acceleration of the elevator. Okay, so in our free body diagram, what forces are present? Tension, and that's going up.
Gravity.
Gravity. Going down. Is there any other forces on the elevator? No, that's it. Okay, so in order to calculate net force, what are we gonna have to calculate first?
Okay.
Yes, right. First, we're gonna have to calculate the gravity, which is mass times 9.8. And the mass we know is 320. So the gravity force is what? 3,136. Okay, so then I can calculate net force, which will be what? 664, 3,800 minus 664 newtons, what?
Up.
Up. Okay, and then acceleration is net force divided by mass. So 664 newtons up divided by 320 kilograms. So equal what did you say?
0.07.
0.7, I had 0.75, so meters per second squared up. What do you guys think about that? Yeah, okay. On your assignment, I just want you to do the back, number 4. You can take a look at the front, we'll talk about it tomorrow. It brings back some velocity time graphs and dot diagrams. But do the back for your homework tonight, which is just number 4 on calculating